Hi out there to whoever is joining us. I'm Justin Karl. Stephen Hall is behind the scenes tonight. We're from the testing group inside the Omega Envoy project, one of your friendly neighborhood Google Lunar X-Prize competitors. And this is how we spend our Friday nights. You might notice that we're tired, and we are, in fact, not out having a good time. We're here in a testing lab with an MTS servo hydraulic testing machine. This is going to apply a uniaxial load with this hydraulic piston. And we're going to read the force with this load cell up here on one of our LDV, Lunar Descent Vehicle, mock-up suspension legs. And basically what we're trying to do here today is verify some of the results we've been getting in our numerical simulations with some real-world hardware. So this is mostly 6061 aluminum. We have an all-steel, very beefy fixture to make sure that there's no movement here, and we're going to apply a load right through center and displace this pad joint upward and see how much these guys can take. We're expecting somewhere near a ton of force before failure, so it should be very interesting. We're going to program the control and acquisition system to stop it short of destroying everything, but we should see some pretty dramatic results. We've got strain gauges in a couple of choice places. So we've got on one of the lower arms here, we're expecting a little bit of tension, and in the middle here we should see a lot of deflection on this arm and get some bending stresses. So we should be ready to go here in just a minute, and if you pay attention to this computer monitor here, we have a readout of the force. Right now it's preloaded at about 100 newtons, and the axial displacement is down here. We'll slowly load it. If you think in English units, we'll be at about 1/4 of an inch per minute. So it will seem slow, but you'll watch that force and it'll jump up pretty fast in the beginning of the test. So Stephen is off camera with our emergency stop in case anything bad happens. Hopefully it won't, and we'll be able to verify these results tonight. Alright, so I'm just setting a limit here. If we get to over a ton in compressive force, we're going to stop, and if we displace this actuator too much, we're going to stop. So we've got those set, and we're ready to go. Alright, so final checks. Everything is preloaded, everything is torqued. Stephen is ready to end the test in the event of an emergency. And we've got a 10-second preload ramp to make sure we're near our 100 Newton preload. Bring up our station controls, make sure our displacement is here at 0. We are ready to go. And we're running. So we barely moved a millimeter, and we're already over 500 newtons, approaching 1 kilonewton, 1.5 millimeters. And change the scale here a little bit so we can see better. Alright, so that's 2 kilonewtons of force. That's higher than we've ever gone without deflecting our rods. So our design is improving. 3 kilonewtons. Okay, the structure unloaded a little bit there, so something settled. Over 5 kilonewtons. Very little visible deflection in the rods. Okay, we're closing in on 16 millimeters, so we're a little bit over a half of an inch deflecting that lower pad joint. We're over 7 kilonewtons of force. The steel pre-tensioned rods on the back of the test fixture are straining faster than our LDV suspension system. It's entirely possible we may break the test fixture before we break the structure we're testing. Yeah, we're starting to see some flexion in the lower rods now. The upper rod arm now is just now starting to flex outward. Okay, so we're nearing an inch of deflection. We're deflecting the test fixture just as much as we are the structure. We're nearing 10 kilonewtons of force. Okay, so we're over an inch. We're at 10 kilonewtons. So we were well over a ton. The structure is unloading. We're going to go ahead and stop now. We're permanently deforming it. Okay, so we'll give it just a couple more seconds to see how it deforms. If you're looking at the force readout, you see that's going down as the aluminum is going plastic. Alright, so we're going to go ahead and terminate this test now. Remember, we've exceeded our expectations, and a failure like this does not mean a vehicle failure on the lunar surface. The idea behind the suspension is, in fact, to take a beating and leave the LDV and the rover intact. Thanks for joining us. We're going to unload this and maybe we can update you via the web in the next couple days.